Hi, guys. We're down to our last 3 weeks of at home learning of geometry. I'm so excited. We're almost done. Today, we're going to do lesson 5 from our circles chapter. I think it's lesson 5. I have no idea. I've lost track. But we're going to do some arc length and area of a sector. I cannot wait, and I know you're super excited to learn what it is. Okay, so the first thing we're going to do, we'll do arc length first, is you have to know what arc length is. So hang on a second. Arc length would be like someone took a string and placed it around the outside of the circle, and then they put it around the circumference, and then they straightened it out. So that would be the length of the arc versus the degree measure of the arc. They're two different things. Degree measure is different. Arc length is put a string around it and then straighten that string out. Okay, so here's what we've got. It has a formula. Everybody loves a good formula. And the formula looks like this. Oops, I better get on my pen. So it's n divided by 360, and I'll tell you in a second what n is. And since we're doing the length of something, you have to think about the circumference of the circle. And the circumference formula is 2 pi r. Or sometimes we see n over 360, and another way to write the circumference formula is pi d. So either of those two formulas work. Now, what is the n? The n is going to be the arc central angle measure. Okay? So let's just look at a basic example first. All right, now this would be if we were to find the length of the arc. So the length of this piece right here, not the degree measure. We know the degree measure would be 60 because of that central angle there, but the actual length of it is what we want to find. Okay, so we're going to take our little formula, n over 360, and I have a radius, so I'm going to use 2 pi r. That's just part of the circumference formula. We're finding the length of something, and the circumference around the circle is using the length. Okay, so now I'm going to do 60 over 360, and then times it by 2 times pi, and my radius is 12. Well, I can simplify things up a little bit. I know 60 into 360 goes in 1/6 time, and 2 times 12 is 24 pi now. Now, I know what 1/6 of 24 is because I'm a genius, and that's why I'm in honors. It's 4 pi. It says leave your answer in terms of pi, so it's 4 pi for the length of that arc. That was super fun. Let's try the next one. Find the radius. Oh boy, I'm going to work backwards, folks. We can do it. Find the radius of the circle, which the central angle of 70 degrees. So I'm going to draw myself a little picture here. Look how nice that is in the center. That central angle is 70 degrees, and the length of this arc out here is 62.5. I want to know what's the radius to the nearest tenth. So I'm going to use n over 360 times 2 pi r again, because I'm looking for the radius. I don't know the radius, but I do know this time the answer to the problem is 62.5. Oh, do I know my n? Oh, yeah, let me get my eraser. My n is actually 70, right? Out of 360 times 2 pi r. Wow, folks, we got to know how to do algebra for this one. Okay, we can do it. 70 times 2 times pi. Really, all of this is over 1. Do you see that? So I really have 62.5 equals 140 pi over 360. And I'm just going to get real fancy, and I'm going to put this over 1 and cross multiply. So 140 pi r, sorry, I forgot the r. That's what we're solving for. Equals, I'm going to grab my calculator, 360 times 62.5 is, wow, 22,500. Now, I'm going to divide all of that by 140, and I'm going to put that pi in there. So I have a radius of 51.569, blah, blah, blah. I want this, 51.1569. So my radius is 51 point nearest 10th. Take that 5, round it to a 2. And that was super fun. When I did back here was when I divided, I put this guy in parentheses in my calculator. So it divided that quantity of 140 pi on both sides. Okay, folks, let's try another. The gear on a grandfather clock has a radius of 3 inches. So basically, I don't know what's going on here. Am I frozen? Oh, look at that. So the radius is 3 inches. To the nearest tenth of an inch, what distance does the gear cover when it rotates through an angle of 88 degrees? So they're actually want us to find the length of that arc. So I'm going to do 88 out of 360 times 2 times pi times my radius, which is 3. So basically that's 88 times 6 on top. So now I have 528 pi out of 360. And if I reduce that down, that turns into 22 pi over 15. It doesn't tell me to round to anything. So I'm going to leave this answer as an exact answer, they call it. And that would be my final answer. And that was your arc length. Okay. Let's talk about the area of a sector next. The area of a sector is basically the region banded by 2 radii and its intersected arc. It's like if you get a pizza. I haven't had pizza in forever. What a bummer. And you were trying to find like the area of that slice of pizza. Wouldn't that be fun? That's called a sector out of the piece of pie. So the formula for that, since we're doing area, it looks similar to the other, that n over 360. We're going to take that central angle and use that as our n. But now since we're doing area, guess what, folks? Pi r squared. So area of a circle formula, pi r squared, versus the length of the arc, which was 2 pi r or pi d, using the circumference formula. I just went running and I'm like super thirsty. So I'm going to hydrate with some coffee there. Okay, so it says find the area of a sector. I didn't shower either, if you can't tell. Find the area of a sector with a central angle of 60 degrees and a radius of 10 centimeters. Okay, so here we go. We got our circle. That's my central angle. Look how nice that is. That's 60 degrees. It's got a radius of 10. And we want to find our answer to the nearest 10th. So now we're going to do 60 over 360. This time it's pi times radius squared. Okay, so we're doing pi r squared because it's area of the sector. Well, I'm going to reduce this to 1/6. This turns into times 100 pi, or this is 100 pi divided by 6. And when I type that in on the calculator, I get like 52.35, blah, 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 which ends up being 52.4. So the area of that sector is 52.4. All right, that was fun. Let's try one of those where we work backwards. So we're going to skip that second one because it's the same idea as the one up above there. But let's try to find one where we're actually looking for the angle. That'll be spicy. Let's do it. Okay, so find the area of the sector ALB in the following image is 28 pi. So they're telling us the area is 28 pi. I'm going to do my n over 360 because I don't know what that central angle is. And then it's going to be pi times 12 squared. Okay, now here's a trick. Since there's a pi on both sides, they're basically going to divide each other out. So I'm going to cancel those out. So they're gone. So now I have 28 equals, well, what's 12 squared? 144 n over 360. Now you can put that over 1 and we can cross multiply. So 144n is equal to 360 times 28. 360 times 28 is 10,080. And then I'm going to divide that by 144. And so my central angle of this sector is 70 degrees. That was super fun. We worked backwards and used our algebra skills. Oh, look at this bottom one. Look at that. Got cut right off there. Darn it. Well, let's try it anyway. It says, given circle O with a radius of 12 and an intercepted arc of 120. So that means this central angle here is 120. Find the area of the shaded segment. Whoa, it's like a piece of the sector is shaded and a triangle in there is not shaded. This actually continues on down here and this guy's shaded here. Now, if this is 120, I can find this area of this whole sector and then I can subtract out the area of the triangle. Okay, so let's try this. The area of the sector is going to be the 120 over 360 pi times 12 squared. Well, I'm going to give us that answer. It all reduces down to 48 pi if you do the math on that. That was not that bad. You could reduce this. That goes in 1/3. This becomes 144. So 1/3 of 144 turns into 48 pi. Now, to do the area of the triangle, it's 1/2 base times height. But I don't know this base, and I need to know this height. But no fear, people. If this whole central angle is 120, each side is 60. So now I'm looking at this angle being 60. This is 90. Look, there's a 30, 60, 90. That was so fun. I threw that right in there. So if this guy's 12, across from 30 is 6, and across from 60 is 6 radical 3. Because if you remember, across from 90 is 2n, this is n, and then this is n radical 3. Okay, so if I were to extend this out, this other piece over here is 6 radical 3. So it's 1/2 of the base, which is 12 radical 3, because 6 and 6 make 12, and the height is 6. Half of 12 is 6, times 6 is 36 radical 3. So I basically have 48 pi minus 36 radical 3. Round your answer to the nearest tenth. If I type it all in, I get 88.4. That was super fun. That concludes our first lesson this week, and that was on arc length and area of a sector. Enjoy and have fun, and I'm going to have some more coffee. Bye.